today we're going to pick up where we left off yesterday on our How Do Computers Work thing. Okay? First, let's do a tiny bit of review. So, let's see who remembers. What is the thing that makes the computer think?
The brain?
The CPU.
CPU. Very good. What do you call the spot where it thinks in? We also called it temporary storage. There we go. Temporary storage is called what? You put things there for a little while. Memory. What do we call the part that talks back and forth to the person? The real world.
The I/O.
I/O. Input, output. I/O. And lastly, where do you put things when you're done with them?
In long-term storage.
So you want to keep something, you go to long-term store. The four basic pieces of computer. Okay? What we're going to talk about today is, we touched on it a little bit yesterday, how does this think? What does think mean? So, let's dig in a little bit to how does a computer think? What we talked about yesterday was a CPU. It is an integrated circuit, remember, that has one purpose. It executes instructions. Remember, it has an instruction set that it's built with. So over here we can write it has an instruction set, which is kind of like a language. You guys know English, right? If I stand up here and I talk in Spanish, what's that going to do for you?
We're not going to understand.
Not a whole lot, huh? Every CPU has an instruction set, and that's the only words that it understands. This is anywhere from a couple of hundred to maybe a couple of thousand. And that's it. That's all it has. So what you do is you take an instruction set and you put it together into what's called a program. A program is just a fancy word that means a set of instructions. Think about it like you go to an event, right? What do they hand you at the door? A piece of paper. What do you call it? You go to like a ceremony, and you walk in the door, and they hand you a piece of paper. What's on the piece of paper?
Could be a map.
The program for
Could be a map. Could be a program for the event. It tells you, here's what we're going to do first. Here's what we're going to do second. Here's what we're going to do third. The program tells you the order of doing. And the only thing it can do is the instruction set that it knows. Okay? So at the lowest level, what you tell a CPU is, this is the program I want you to run. This program is a certain order of these instructions. So let's say we had a real simple CPU and it had 5 instructions. Okay? And the instructions are add, move, subtract, let's call it change, and put. And that's all it knows. It knows those words. Okay? So, to write a program. Writing a program means I'm going to tell it, of these 5 things, I want to accomplish something. Actually, instead of change, let's use the word get. So we have an instruction to get something, to put something, to add something, to move something, and to subtract something. And that's what it knows how to do. So, let's write a program. First, what if we get a number? What if we move that number here? What if we get another number? And then we move, let's call this to A. And we move this number to B. What we've done now is from somewhere on the I.O., we got a number. And we moved it over to location A. And it's sitting there in memory, because that's where we think in. Then we say, let's get another number from I.O., which is like a keyboard or something. And let's move that number over to location B. Now, what we've done is, we've got one number sitting in this box over here that's called A. Let's say it's a number 10. And then this one had another location called B, and let's say that's number 20. Now we say, I want to add these, A and B. Then, I want to put the answer. What we just wrote is a program. We took these instructions, we got a number from the keyboard, we moved it over to a location where we can remember it and use it later. We got another number from the keyboard, we moved it over, then we added these two together, which came up with an answer, and we put an answer out on the screen. This is a program. And that's how computers work. It's actually really simple at the low level. And believe it or not, when you're watching a movie on your laptop, this is what's happening billions of times per second. That's what computers do. The amazing thing is that everything that happens on a computer can be broken down to something this simple, just a whole bunch of them. For instance, let's say we're talking about a screen. You know what a screen actually is? The screen on the computer is a bunch of dots. They're so small you can't see them. There's something like 10,000 dots on a typical screen. That's how small they are. If you sat there and counted them, some of them have more. When you look at a camera and it says megapixels, mega equals 1,000,000 and pixel equals a dot. So think about this. If you have a camera with 5 megapixels, you know what that means? On this little screen, there's 5,000,000 little dots. And every little dot records a piece of the picture. When you back up and look at all those dots together, you see the picture. You don't see the dots anymore. If you took a microscope and you looked really close, you know what you'd see? Little tiny dots. So, let's bring this back to our program. Our screen is a bunch of little bitty dots. Let's say, well, every dot is addressable. That means you can get to it. So there's these things called XY coordinates, okay? X means this starts at 0 and goes to 1,000. And Y means it starts at 0 and goes to 1,000. So this dot is 0, 0. This dot is 10, 0. See how that works? So I can use coordinates to reference any individual dot. That's how a screen works. Every individual dot has two numbers that describe where it is, starting from usually the top left-hand corner. If it's 1000, 1000, it would be this dot right there. Now let's say that the number you send this dot represents how bright it is. So 0 equals off, 100 equals middle, 200 equals bright, and 256 equals blinding. So here's what I'm saying. The screen, I/O, every dot on the screen has numbers that can tell you which dot you're talking about. The value you push to that number determines how bright that dot is. Okay? Real simple mechanism. That's how I/O works. So now, if I say I want dot 0, 0 to equal 100, what does that mean? This dot right here is 0, 0. 100 means, oh, it's a mid-level brightness. So he's just a little bit bright. If I say dot 0, 1 equals 200, that means the dot next to it is a little bit brighter. If I say dot 0, 2 equals 300, that means the one next to it is even brighter still. So this is how I/O works. It's all based on math. Everything in a computer is based on math. Now, let's think about our program. Our program is getting two numbers, adding them together, and putting an answer. So let's do something useful with it. What if I put in a number here, I put in the number 10 on the keyboard, and I put in a number 10 again on the keyboard, and this, where it puts the answer, is dot 0, 0. What have I just done? I just pushed 20 to that dot. Because the number I put in and the second number I put in gets added together, and the result goes to that dot, which makes it whatever number I put. If I put in 100 and 100, that dot's going to equal 200, which means it's going to be bright. If I put in 0, 0, that dot's going to equal 0, which means it's going to be bright again. So what my program does is control the brightness of spot 0, 0 on the screen. I've just done useful work. I can, at the keyboard, punch in two numbers and have that tiny little spot on the screen show up as bright as I want it to be. I know that's really simple and silly, but believe it or not, that's what's happening when you're watching a video. But every single dot of these 5 million spots is being controlled, and instead of pushing in from the keyboard, it's coming from the stored video stream of the movie.
Which is the program.
Which is the program. The program says, get these numbers. If you're watching a video, it's getting it from the CD-ROM or from YouTube or wherever. And then it puts it at the right spot. It's really simplified, but that gives you the idea of what our program does. Let's take another example. That was an example of how I/O works. Now let's give you an example of a program. Well, I have to go one step further first, okay? There is levels to program. So every CPU has an instruction set. And if you live in that instruction set, it's called machine code because it is the code that the machine understands. You can also, some people call it machine level. The instructions that I listed are really simplistic. They're hard-coded, built into the CPU. That's actually all it ever understands. It's those really simple movements of move this number here, add this number to that. That's really all it does. So it takes a whole bunch of these to accomplish anything, right? Because if you want to draw a screen, you're going to have to do a whole bunch of stuff. If you want to have it figure your taxes, you're going to have millions of these. So what's happened over the years is instead of talking to the CPU in its native code, this is also called native code. There's all different ways to refer to it, but all of these mean the language that the CPU itself understands. What's happened is we say, okay, that's just really complex. Because in order to do that, you're actually writing the numbers out. Remember what I said about my computer with all the little switches and lights, and you have to set up the switches and say store, and set up switches and say store? That's machine code. It's way down here at the bottom. Okay? And that is what the CPU understands. So ultimately, every program gets converted to this very bottom level of machine code. To make life easier so that you don't have to punch in the actual numbers and hit store, they invented this thing called assembly. The assembly level. This is one step up, where instead of talking to it in numbers, this is nothing but numbers. This is names. So, where this, you have to say, okay, that instruction is represented by number 65, so I'm going to punch in 65. This instruction is represented by 72, so I'm going to punch in 72. This is actual numbers you have to look up and punch in. This one is names, like move, add. It's the same instructions, but now it's a name instead of a number. So it's one step easier, right? Because now I can look at it and I know, oh, instead of saying 72, 64, 53, I can see move, add, put. All that's happening is at this level, something else is looking up what these numbers mean and putting it in more English terms. Okay? Still not very useful, because we still have to have millions of these to do anything useful. So then we started doing, let's call it, the next level is BIAS, which stands for Basic Input-Output System. So what they did is they collected up a bunch of this stuff for the computer we're talking about and said, I'm going to give things that I routinely do a name. Some simple things. So now I have instructions in English. I can say, read keyboard. The BIOS says, when I see read keyboard, I'm going to convert that into this series of machine level codes. So it's a level higher. It's like, instead of using a bunch of little tiny words, I use great big words. So now I have fewer words. Where here, if I wanted to read the keyboard, it would take me 100 of these. I can just say, read the keyboard. Then we go up another level. To what we call higher level languages, and there's a bunch of them. This is where things get easier. So now, instead of just things about the computer, there's all kinds of, it can be anything I want. It's collections of these put together into meaningful things. You can have a word up here that says, say hi. And that might be 1,000 of these, but all you're writing is one of these. Okay? So there's levels to programming languages, and the higher you go, the more of these at the bottom get executed. So what we're going to talk about, just to expose you to it, is what do you do up here? I'm going to show you a real program. The traditional program. The simplest way to write a program is called procedurally. Procedural programming means this is how I want you to proceed. Do this, and then do this, and then do this, and then do this, and then do this. This is a real simple program. Let's say I have a command called input. And what I can do is say, I want to input, and I want it to give me a prompt saying, name please. So what's going to happen when I run this program, if that's the only line in my program, here's my screen. When you start the program up, it's going to say, name please. And it's going to wait. And it's not going to do anything because this command says, display this part, and then wait for answer. And store it into A. Okay? So it's going to say, name please, and the cursor is going to be blinking here, waiting for you to put something in. So you type in Levi and hit enter. Now it moves on to the second segment. And let's say here's my second command. What it says is, this command says print to the screen this word and then whatever the person typed in location A. So now it's going to say, hello, Levi, and it's going to stop. And I just wrote a program at a high level language. I'm not dealing with numbers or anything. I'm writing in an actual language. This happens to be a language called BASIC. It's an actual computer language. These are actual commands. There's an input command that says, put this on the screen, wait for an answer, and put the answer into this location. There's another command that says, print this on the screen, and then after it, print whatever's in this location. By putting those two together, the computer just said, hello, Levi. If I come over here and I type Bob, what's it going to do? When I run the program and I type Bob, what's it going to do? What does this mean?
It's going to say hello, Bob.
Exactly. Hello, Bob. You have a program that can now talk to you in two simple lines. Now understand, underneath, to do these two simple lines is probably on the order of 2,000 machine level instructions that had to happen. But all those things, those routine things like this, are wrapped up into this one command.
You were doing this the other day. I was watching
Yes.
with the Bitcoin thing. You were programming something.
There's all different languages. There's different types of languages, but they all work basically the same. It's collections of this math that we talked about. Moving numbers around is all it's doing. Writing letters to the screen is no different than painting coordinates. It's exactly the same thing. That's what's happening behind the scenes. So this looks really simple. You can look at this and say, oh yeah, this is going to let me input a name, and then it's going to print hello and the name that I input. That's really easy. If you saw the 1,000 different instructions and numbers down below, you would not know what it's doing. So this is what high-level languages is what make computer programming available to the public. You guys, if you learned very simple languages, look, with two commands, you just made the computer talk to you. You could, let's add another command to our program. Let's say I want it to tell me something else. After it says hello and the name, let's say the name again, and then put, you are cute. Now when I run the program, it's going to pop up, say name please. I'm going to type in Bob. It's going to pop up and say, hello Bob. And then it's going to say, Bob, you are cute. Let's have a little conversation with this thing, shall we? How about if we say input, what? Your favorite food? B. What's it going to do now? What? I'm not going to do the whole thing. Is your favorite food? And it's going to wait. I'm going to type in ice cream. Over here in our program, what I want it to do is say, I like beef. What's it going to say?
It's gonna say I like ice cream.
I like ice cream. You just had a conversation with a computer. Whatever name you type in, it's going to say, hi, you're cute. Whatever food you like, it's going to say, I like that food too. That's a program. Now, here's a nice little trick. Right now, the computer, when you say run, it's going to do this and then it's going to stop and go to sleep again. If I add one more instruction that says, go to 1, what do you think is going to happen? You notice all these commands have line numbers on them? So what's going to happen on our screen?
Name, please.
Name, please. You just made a loop. And it's going to run forever, never stop. Because every time it gets down to the bottom, it goes, oh, let's go back up here. And it runs forever. So it'll just keep asking. Name, please. Joe. Hello, Joe. Joe, you're cute. What's your favorite food? Tamales. I like tamales. Name, please. That's how programs work. We tell it what to do. Part of it can change with you, and part of it doesn't. You can make this thing say anything you want. Now, here's the thing. We say the CPU is thinking. Is it really thinking? Does it really think you're cute?
No.
You told it to think you're cute. Computers do not have intelligence like we do. It cannot answer a question you have not given it. There is stuff we're not going to talk about, artificial intelligence, but at the level of computers that we use, they don't actually think. They follow instructions perfectly. It will do this billions and billions of times until you turn it off. It'll never complain. It'll never change. It'll never come up and say, I don't really think you're cute. So when we say computers think, what we mean is they think enough to follow instructions. Kind of like if you train a dog, so you throw a stick and he's going to go grab it and bring it back to you. Is he thinking? Yeah, kind of. He's thinking enough to follow instructions. What a computer can't do is run up to your lap and lay its head down and love you. Because it's only following instructions. Now, there are some very complex things that can do artificial intelligence, but we're not even going to talk about that at this time. All the computers we work with today are like this. They're only following instructions. Even though it might seem like it's real, it's actually just following instructions. Okay? So that gives you an idea of what we mean by a program. You can write a program to do anything you want to do. And that's what makes computers handy, because they follow instructions perfectly, repetitively, and they never change. Every time you turn on a program, it'll do exactly the same thing, unless it's broken. Okay? So that's what we call programming.